Alright, this is your video for 5.3. We're skipping 5.2 because there wasn't much of that, or any of that rather, on the EOC last year, and it's not looking like there's going to be any this year, so we're skipping that one, going straight to 5.3. Now, 5.3 has traditionally been a very difficult section because there's so much vocabulary and so much algebra. Hopefully the algebra won't be an issue for y'all since you had a decent year last year. But let's look at some vocabulary. So a median of a triangle is a segment whose endpoints are on the vertex of the triangle and the midpoint of the opposite side. So just like the definition said, a median goes from a vertex to the midpoint of the other side. So since there are three vertices of a triangle and three midpoints of the three sides, then there are three medians in any triangle. And when those medians run into each other, it's called a centroid of a triangle. So that's what we have on our, that we're going to find first here. The centroid, which is where the medians meet, will always be inside the triangle. Because it's going from vertex to side, they have to cross inside the triangle. The centroid is also called the center of gravity because it's the point where the triangle would balance. So if you think about a triangle as like a piece of paper and you were to stick like the pen underneath it, if you found the centroid, that would be the point which would make the paper triangle balance. Okay, so let's look at the centroid theorem to see what's going on here. So here you can see that we have the three centroids. We have B going down to Z, C going across to X, and A going across to Y. So these three centroids are all running into each other at point P. So P is the centroid of this triangle ABC. So what the centroid theorem says is the centroid of a triangle is located 2/3 of the distance from the vertex to the midpoint. So we say this, how I say to remember it is 2/3, 1/3. Now, 2/3, 1/3 isn't like half and half. It isn't super close, so you can tell which is the bigger side, which is the smaller side. So you don't really have to memorize. But if you wanted to, the bigger side is always the side closer to the vertex. So from the vertex to the centroid is 2/3. From the centroid to the midpoint is 1/3. Vertex to the centroid 2/3, 1/3. 2/3, 1/3. And you can tell all of the medians are not going to be the same length. This one, AY, looks a lot longer than BZ does. But that's okay. All that matters is that it's cut proportionally. 2/3, 1/3, 2/3, 1/3. And then you'll be able to find the middle right there. Okay. So let's look at a plain example. So in triangle LMN, RL, so the whole distance is 21. We need to find LS. So LS is the 2/3 side and RS is the 1/3 side. So all we have to do is multiply 21 times 2/3, and that will give us our distance. So this is going to be 7. 7 times 2 is 14. So LS would be 14, RS would be 7. This would still add up to 21, but this side would be twice as long as this side, so I know I did that part right. Okay, let's try NQ. So SQ, this little piece over here, is 4. So that is 1/3. So if we doubled that to get 2/3, we'd be on the other side over here and we'd be at 8. So the question is, how long is the whole thing? So this piece is 8 and this piece is 4. So the whole thing is 12. And if you wanted to do 12 times 1/3, 12 times 2/3 to double check, you get 8 and 4, and you would get that right. So as long as you remember the centroid theorem says 2/3, 1/3, then you're good to go. Okay, so let's look at an example on the coordinate plane and a word problem example. Alright, a sculpture is shaping a triangular piece of iron that it will balance on the point of a cone. At what coordinates will the triangular region balance? So if we're trying to balance, we know we're trying to find the centroid because we just talked about that. Centroid means center of gravity, so it's where it's going to balance. So what I have to do is I want to go from endpoint to midpoint of the other side. From endpoint to midpoint of the other side. So let's start by finding all of the midpoints. So I'm going to start with this. We've got 6, 6, and 10, 7. Remember, to find a midpoint, you just add them up and divide by 2. So we have 8, 6.5. So we're going to go 8, 6.5. And that will be the midpoint here. Okay, let's come over to this side over here. So let's still use 6, 6, and let's use 8, 2. So we're going to add them up. 14, 8, divide by 2, 7, 4. So this is the midpoint here. Now, this is all you have to do. You only have to find 2 of the sides, because wherever they run into each other, so are the other sides going to run into each other. So all you really have to find is 2. If you want to be absolutely sure and find the third side, that's not a bad idea either. It doesn't take very long. So I'm going to look at this one and see how close I can be. So you're connecting the midpoint to the vertex of the other side. The midpoint to the vertex of the other side. And what I want to know is, where do these 2 points intersect? And if I did the third one, you would see that the third one would run right through the middle right here. So that's why we only have to find 2. It's because the third one's going to run through there automatically, but you can always find the third one just to check. So I need to find this point. Since this line, this median here was vertical, that gives us a good indication that the first coordinate will be 8. Then we just need to look at y. That looks like that happens at 7. So this coordinate where these 2 medians intersect is at 8, 7. So my centroid is at 8, 7. Okay. Alright, so that is median and centroids. Now we're going to talk about altitudes and orthocenters. So this one's a little bit trickier. You know the word altitude already, because you know it means height of a triangle. And we've talked about what that means, that to be the height, it has to be perpendicular. You're looking for that right angle to be the height. So this is still true with altitude. The definition of altitude is it's a perpendicular segment, meaning a right angle, from the vertex to the line containing the opposite side. Notice it doesn't say to the opposite side, because it could have to be outside the triangle, like we're fixing to write. An altitude can be inside, outside, or on the triangle. So it doesn't have to be exactly inside, which is a little confusing for us. We're not used to seeing that. Okay? So inside, outside, or on the triangle. Alright, so let's look at this diagram right here and try to dissect this a little bit. Okay, so this altitude is the one that we typically think of. If you look at this triangle, if I kind of turn it on its side, if I ask you to find the height, you would say, oh, here's the height right here. Here he is. Which is true. And that would be, if we were just trying to find the area, that would be the height that we would find. We would draw that guy in and we would call this guy our height. But every triangle has 3 altitudes, so the one that you're looking for is there, but there are 2 other ones. Those are a little different because they happen to be outside the triangle. So here's what we're saying. If I want to go from R over across to this side, QS, there's nowhere that I could draw this and draw a perpendicular line. If I draw here, that's not perpendicular. If I draw here, that's not perpendicular. Even this angle right here is not 90 degrees. I have to keep going. So here it is. They've drawn it for us out here. I had to extend this line QS out until I could swing this line to be exactly perpendicular. And once it's perpendicular, this is my altitude. These weren't altitudes because they weren't perpendicular. They weren't making the right angle. So this one is the one that makes the right angle. So it gets very confusing when you're drawing these 3 lines, and some are inside, some are outside, so I know that's tricky. And then we can switch over to the other side. Let me grab a different colored pen. I'm going to switch over to the other side. I'm going to start on this point S, and I'm going to try to get it to where I can be perpendicular to the side RQ. So where can I go to be straight up and down? Well, it's not towards the triangle if this one happens to be outside as well. I don't end up being exactly a right angle until I'm way over here outside the triangle. So what happens, let me see if I have a third color. So what happens, this purple altitude over here, this orange one right here, and the one that we like, the one that makes sense to us, this blue one in here, they all end up meeting, I'm going to extend my purple one out, my orange one out, they all end up meeting way out here outside the triangle. The original triangle is over here, but these altitudes don't meet till out here. And the point where they meet is called the altitude. Okay, this is not always so confusing. If you have a right triangle is very easy to do because the legs are already 2 of your altitude. Okay, this is your right angle right here. So this is one altitude. Look, it's going from a coordinate, from a vertex, and it's perpendicular to the opposite side. Same can be said for the other side. This is going from a vertex, and it's perpendicular to the opposite side. Then I could draw my third one in here like this. This is going from a vertex. I didn't pick a very good one, did I? It would probably be more over here. And it is perpendicular to the opposite side. They're all meeting right there at the right angle. The right triangle is the one you're hoping for when you're looking for an orthocenter. I didn't call that the right name, did I? When you're looking for an orthocenter, which is where your altitudes meet, you're hoping for a right triangle. Because anytime you have a right triangle, the orthocenter is that vertex where the right angle sits. If it happens to be an acute or an obtuse triangle, you're kind of stuck. You're going to have to find it out. Now, in an obtuse triangle, it's going to hang outside. In an acute triangle, I didn't draw this one very big, but in an acute triangle, the altitude will be on the inside. It'll look more like the centroid, but it won't be a median, it'll be an altitude. So the orthocenter will be inside. So obtuse triangles are the hard ones because it's outside the figure, and that's a little confusing to look at. Right triangle's the best, and acute's not quite so bad. Okay, so let's do one of these. Find the orthocenter of triangle XYZ if X is at 3, -2. Y is at 3, 6, and Z is at 7, 1. Now this is gonna be a lot of algebra because you know to find an altitude you're gonna have to be perpendicular. So remember, we know perpendicular means opposite reciprocal slopes. Now, one thing, just like we did with the median, we only had to really do 2 of the sides, and then we could find wherever those 2 intersect, the third one has to intersect. We're going to do the same here. We're only going to find 2 of the altitudes, and we'll just know that the third one would happen on its own. Okay, now what's going to happen to be nice to you is most of the time one of the sides is either going to be a vertical line or a horizontal line, and that's to make this nice and easy. So in this case, XY is a vertical, so that means it has a slope that is undefined. So what is going to be perpendicular to that would be a horizontal line. So all we're looking for is we're looking for the horizontal line that goes through point Z. So that would just be this line right here, because there you would see the right angle. It's going through the vertex of the other side, and it's making a right angle right here. So this equation, we practiced writing equations of horizontal lines. This equation going right here is y equals 1. Remember, it crosses the y-axis, so we use a y. Where does it cross? It crosses at 1, so this equation is y equals 1. So you always want to look for that vertical or horizontal line first, because that's going to make the problem a lot easier. There's half your work already done without any algebra at all. Then the other one you're going to choose, I could choose this side or this side, it doesn't matter. Whichever one you do, it's still going to work out. So I'm going to do this one down here at the bottom. So I'm doing XZ. So the first thing I want to do is find the slope, so I'm going to count. From -2 to 1, that has a rise of 3. And from 3 over to 7, that has a run of 4. So XZ has a slope of 3/4. So I want to be perpendicular to that. So we're going to do the opposite reciprocal slope. So I'm looking, I didn't even do opposite reciprocal, for a slope of -4/3. Now remember, it doesn't go through these points, it goes through the opposite point. So it's going to go through the point 3, 6, and it's going to have a slope of -4/3. So you know what we do with that. If we have a slope and a point, we put it into point slope form. So here we go. Y minus 6 equals -4/3 x minus 3. Okay, now last night we got to just leave it right here, but today I actually need to solve it all the way out, so I'm going to do that. Y minus 6 is equal to -4/3 x. Distribute here, the negatives cancel and the 3's cancel, and just leave you with 4. Move the 6. So the equation for this line right here is y, for this altitude, is y equals -4/3 x plus 10. So if you wanted to draw that in, you could. 1, 2, 3, 4, 1, 2, 3. Ooh, this almost touches that line right here. So it's going to go through right there. So you can look and see these are going to intersect very close to Z, but a little inside of Z. So let's look. What we're going to do is we have a system of equations. Y equals 1 from here, and y equals -4/3 x plus 10 from here. And I just need to solve these. So you could get out your calculator and you could do graphing, but it would even just be easier to do substitution. I'm just going to substitute 1 in for y in this equation. So 1 equals -4/3 x plus 10. Let's move the 10. -9 is equal to -4/3 x. Multiply by the reciprocal. So this would be 27/4. What does that work out to be? So that works out to be 6.75. So I could tell it's very close to 7.1, but instead it is 6.751. That looks like a comma. That's a decimal. So there's my answer. That's where my ortho center is. So I know this is a long problem full of lots of algebra, so you might want to look at the one in the book. It does the same example with the same problem with a different example, or rewind and watch this video again. I'm going to recap it really quickly. So you're looking for 2 of the 3 altitudes, because wherever 2 of them intersect, the third one's going to go through there too. You're also looking for, is there a vertical or a horizontal to make this easier? If there's not, you have to do this process where you do point slope twice. Then you're going to have 2 real equations that you're going to have to solve that system. So you want to try, this one has a vertical line, so I know the perpendicular of that would be the horizontal line. So I drew my horizontal line going through Z, and I called it y equals 1. So that was 1. Then I counted the slope of another one. So this slope of this side was 3/4. So I said to be perpendicular, I would be -4/3. I want to go through the point 3, 6. So I did point slope form, solved that out into slope intercept, and got the equation for this orange line cutting through here to be y equals -4/3 x plus 10. So then I used my 2 different altitudes in a system of equations. Here's the first one, here's the second, and I solved the systems of equations using substitution, and I got my answer, my orthocenter, to be at 6.751. Okay, see you tomorrow.